Now we have to how to solve this particular problem. Log of a to the base x. So this statement can be written as, say, y is equal to, we'll keep y is equal to log of a to the base x. So the similar can be written by using the logarithmic rule. So log of a divided by log of x. So y is equal to the log of a divided by log of x. So whenever I take the derivative on the both of this particular, both the sides, so like this, y is equal to log of a divided by log of x. So I can take the derivative on the both the sides. So dy by dx is equal to, so derivative of this term with respect to the x. So log of a divided by log of x. Okay. So in this particular, we can see that log of a is a constant because small a is considered as a constant in mathematics. So we can take this constant outside of this particular derivative term. So log of a into derivative of log of x, 1 upon log of x. Okay. So I can put this like log of a into derivative of, so log of x, whenever I keep it in a numerator, so it will become log of x raised to minus 1. And now how to solve this particular problem now? Now this is equal to, so dy by dx is equal to the log of a as it is, and the derivative of, now it is a composite function. So log of x is the one function and inverse is the second function. So it is the first function actually and it is the second function. So it is a composite function. Now we know how to calculate the derivative for the composite function. Okay, so we will solve this first of all. So derivative of something raised to something is equal to the power comes in multiplication, and then the power of that something, some term will be reduced by 1. So minus 1 it will become minus 2, and again we have to consider the derivative of this particular log of x. Now it's done. Now it is a minus 1, so I will keep the minus log of a into log of x raised to minus 2 into derivative of this log of x is 1 upon x. So it is solved. So now the dy by dx is equal to, so minus log of a into log of x raised to minus 2 divided by x. Or I can also write down this like a dy by dx is equal to minus log of a divided by x into log of x its square. So it is our final output. Now this particular problem, okay, x cube minus 2x minus 1 raised to the 5. So it is a composite function. Why? Because it is the first function raised to power of something. Now it is the composite function in this particular expression. How to solve this particular problem? First of all, look at the problem. Now identify that it is a composite function. Why it is a composite function? Because the first thing is like this, it is the raised to power. Okay, so it is the first function and this expression is a second function. So it is a composite function. Okay, so we will let us suppose that y is equal to this particular expression. So x cube minus 2x minus 1 raised to the power of 5. If I take the derivative of this with respect to the x, so it will become the derivative of this particular term. Okay, some function raised to the 5, so it will, power comes in multiplication and then the power will be reduced by 1, and then we have to take the derivative of this particular first function, so it will become x cube minus 2x minus 1. So it will be as it is, so x cube minus 2x minus 1 raised to the power of 5. Then the derivative of the x cube is derivative of this x cube is, power comes in multiplication and power will be reduced by 1, minus 2 is a constant as it is, derivative of this x is a 1 and derivative of this minus 1 is a 0. Now this will become 5 x cube minus 2x minus 1 raised to the power of 4, 3x square minus 2. So it is our final derivative. So we have to just identify that it is a type of the composite function. Okay, so again it is a composite function. So the first one is a cos function, it is the first function, and x square plus a square, it is the second function. So we will consider this y is equal to cos of x square plus a square. So dy by dx, derivative on the both of this term. So the derivative of the first function is, cos derivative is a sine but minus sign. Okay, x square plus a square, and then remaining derivative of the second term, that is a x square plus a square, then minus sine x square plus a square as it is, and the derivative of this term, derivative of this x square is 2x and derivative of a square is 0 because it is a constant. Now this will become minus 2x into sine of x square plus a square, so dy by dx. So it is very simple and straightforward. Just we have to identify the given problem consists of the composite function. Given function is a composite function, then we can take the derivative of that particular composite function. Okay. Now look at this particular problem. Now it consists of the three functions. Okay, so the first one is, let's suppose this is equal to, first function is a square root, means power, that is power raised to 1 by 2. Second one is a sine function, and the third, it is the first function, it is the second function, and the third function is x cube. Three functions are there. Okay, so y is equal to, let's suppose, square root of sine of x cube. Take the derivative on the both the sides, so dy by dx is equal to derivative of this particular square root function, x cube. Now the derivative of this square root we know, 1 upon 2 square root of that particular term, means sine of x cube, and then again we have to take the derivative of this particular sine of x cube. Now I have to calculate the derivative of the sine function, so it will be as it is, so 2 square root of sine x cube, derivative of this sine is cos s cube. Now again I have to take the derivative of this x cube, and now the finally I am getting the output as dy by dx, which is equal to 1 upon 2 square root of sine x cube, then cos x cube, and then the derivative of this x cube is 3x square. So finally I will get the output dy by dx is equal to 3x square into cos x cube divided by 2 sine of x cube. So this is our final output. So whenever you look at the problem, so initially you may feel that it is a complex problem, but if you identify the number of the functions which are present in that particular problem, then it becomes simple to take the derivative of that particular composite function. So the composite function is a function in which one function depends on the another function. Okay.